That's better. Alright, so just to describe a reflection then, what did you put as an answer? When you reflect one side to complete an image, you end up with one line of symmetry. Okay, so I did ask you what is more difficult if you don't use a vertical or horizontal line to reflect it. So basically what I meant by that was, if you're reflecting in a horizontal line or you're reflecting in a vertical line, those are the ones most people find easy. But if you reflect in a diagonal line, okay, people find it more difficult. So what was the solution we talked about? The rule to apply a reflection is to do what? Joe? Yeah, so wherever your point is, you always go perpendicular to the mirror line. So I go perpendicular, which is at right angles. I go perpendicular the same distance. So if that's the object A, the image is at A dash. The same here. Let's say I've got object B, we go perpendicular to the line, therefore image of B is there. Now if we've got a point here, actually I'll change it a bit, put a point there, what a lot of people would have done, and a few of you did, was go across to the line and go that way, right? But that's not perpendicular, so what we have to do is go perpendicular to the line and go the same the other side. So if that's the object, that's the image, so it's at 90 degrees. So it's always at 90 degrees to that line. Okay. When we describe a reflection, 2 marks, reflection in, and then the equations of mirror lines. So how can we sum up very quickly equations of mirror lines? So again, if I've got a horizontal line, so it's going that way or that way, the equation of that line will basically be in the form of what? Anyone? Pick up. Y equals something. So if I said that line would be y equals, and then put a k, so it could be y equals 3, y equals 2, y equals -1, that kind of thing. K could stand for anything. Does that make sense? If I drew a vertical line, that equation would be, sorry, not y equals, it would be x equals, and then I'll put a k to stand for any value. Okay. The special ones, obviously, y equals 0 is also known as the what? Not the origin, that's a particular point. This is a line. Which one? The x-axis. So the x-axis is y equals 0, and therefore the x equals 0 is the y-axis. And then the other two we needed to know about were the 2 diagonal ones, one going that way, one going that way, and we know that this one would be
y equals -x.
almost that way.
Oh, positive.
Yeah, so this one would be y equals x, because every coordinate, it would be like doing -1, -1, 0, 0, 3, 3, for instance. All the coordinates are the same. This one, going in this direction, would be y equals
-x.
x, because the coordinates would be, for instance, 1, -1, and so on. Okay. Now, just a little note here for this. Maybe you want to add it to your notes. Y equals -x is the best way to have it, but is it not the same as -y equals x? Is that the same thing?
Yeah.
Does it give you? So if -1 would be 1, which is the x coordinate. Okay. So it can be either way round. All right. But obviously the orange one here, this is the one we want to see. This one would be a bit, well, technically correct, but a bit messy. Alright? So, just looking at some of these shapes then. Very easy. Just to say, so we go perpendicular to the line that way, do the same the other side, and we end up with our image there. This one, nice and easy. They're all fine, aren't they? You're all happy with those. These ones were the ones we were talking about, the diagonals. So again, if we go same size, so I've got 1, 2, 3, so I'm going to go 1, 2, 3 the other way. So my shape will end up like this. And this one, why was this number 6 easier than number 5? Pardon?
You could just use the outside.
Just use the outside, but what is it about one of the lines? It makes it really...
easy and angle.
It's parallel.
It's parallel. So because that line is parallel to the mirror line, it's easy to do. Makes perfect sense. This one doesn't have one parallel, which is why it confuses people. So this one, again, you go 1.5, so I'm going to go 1.5 the other way. So I end up with getting my triangle like this. Okay? Right. On these pages, not necessarily going to draw them all. Where is the x equals 0 line?
The y-axis.
The y-axis. So this is the mirror line that you're reflecting in. Right? So on all of these, this is the mirror line. So your h is going to be over here. This diamond is going to be over here. This thing here is going to be there. And the arrow is going to be this way and pointing that direction, isn't it? Okay? So generally you got the right idea. You just have to make sure the squares are... Okay. Have you got onto the y equals 0 ones already? Yeah. So the y equals 0 line would be this line. So we've got a h here.
Hey, you got that. Got that.
Okay.
Dab, dab.
This one would be down here. This arrow would be there, facing the same direction. Okay. If you've not finished, don't worry. I just want to... Right. Just looking at these. If you've not got there, turn to it now. Let's have a quick look. Because this is the important bits. The equations which are not 0. So if I've got x equals 1, where is the line x equals 1?
After the y-axis.
Okay, so x equals 1 would be right there, going through. So your L shape would be reflected. Now there is a common mistake in that even though people draw that line, they still reflect in the axis. And it gets wrong. Okay? So be very, very careful that you actually use the mirror line. So here, look, we know we've got 4 squares to the mirror line. So my image must be 4 squares the other side of the mirror line, not the axis. Okay? Alright? So my L shape, once I've got 1 point, to be honest, the rest of it's quite easy to draw, isn't it? So my L shape should look like this. Okay? Make sense? Okay. Right. We'll come back to these. I'll let you finish them off. But what I would like you to do in your notes, to go back to your notes, I would like you to consider these now. Just individual points. Alright? So in your books, we can go back to your other ones. It's no problem if you finish them. I can have a look and mark them. That's fine. I will want to take your books in to check the notes you took as well. So you can put them in. Right? We'll talk about it in a minute if that's an issue.
Yeah, you might know what.
Are you doing these?
Is y equals x the same as x equals y?
Yeah, because an equal sign just means one side's equal to the other, so it doesn't really matter. Yeah. X equals y, y equals x. Yeah. Good point. All right. So Are we all in our notes? Some of you are still carrying on with the drawing. Lovely, but let's have a look at these. Be specific to what, maybe more like an exam question is going to be. So, individual points reflected in a mirror line where you don't actually have the diagram drawn. So what I would like to do, maybe you can use the grids that you've got on your other sheet if you need to, no problem if you do. Write down where the point would be after it's been reflected in this mirror line and see whether you can spot anything about the coordinates that would help you so that you don't need to do it in the future. All right? Think about, again, like I said with rotations of functions, what changes and what doesn't change. If it doesn't change, think about why it doesn't change. If it does change, think about how it changed and any way of predicting it. Okay? Does that make sense? So have a go at these. I've got a couple more below, so have you written that down now? It's not that important. So, there you go. So I think they're the points I would like to do in those mirror lines. Okay? It just says what happens to points. So just put it however you want to interpret it. What happens to the points after they've been reflected? Okay. So have a look, see whether you can figure out the point here reflected in this mirror line. What's the coordinates of the new point? Okay. Use the grid if you need to. If you don't need to, great, but maybe you might need to check just in case.
The x equals 2 and the y equals 2. I don't know what's going on.
Alright, shall we have a quick look then? So, if I reflect
Did you get minus 4?
3, 1 in x equals 0, what doesn't change? What? Just which one doesn't change? The y coordinate doesn't change. If you're reflecting in x equals, the y coordinate doesn't change. Okay? So actually I can go straight to the y equals, and which coordinate won't change?
Yes.
The x. So I'm going to write 2. Now I'm going to then, I know this is not the way you've done it, but if I go to these ones then, if it's being reflected in x equals, which one doesn't change? The y. So the 6 should stay the same, and if it's reflecting in y, the x shouldn't change. Okay? So you've got that bit. So we've just got to figure out what does change and how. So 3 for the x reflects in 0, so it becomes negative 3. So if I'm reflecting in x equals 0, that looks nice, doesn't it? It just becomes negative. Right? Therefore, y equals 0, the 3 will become a negative 3. Okay? It's almost lunchtime, so I'm doing this very quickly. So if I'm reflecting in x equals 2, however, and it's at 1 now, where's it going to go?
3.
It'll go to 3, because I've got to go up to x equals 2, so I've got to go another one. And then y is minus 2, so minus 4 down to minus 2 is a difference of 6. So I've got to keep going another 6, and it's
8.
negative 8. Cool. What did you notice about a reflection in y equals x? They swap. So it becomes 2, 5. What do you notice about y equals minus x? They swap and become negative. So is it negative 4, 0?
Yes.
Okay. So there's a few things to notice there about points that might help you. Okay. Right, just to say, before you stand up and go, I am going to set you another paper 6 for homework. But I'm going to attach it and send it on Firefly, so you'll have to print it off for yourself. If that's a massive issue, let me know and we'll try and sort it out. But I'll put it on Firefly and attach the document. Okay, I'll put it all on Firefly so you can write it. I'll put it up this afternoon. Yeah.